Hey everyone, so we are continuing our note on page 4, and we're talking about solving equations by using the distributive property and collecting like terms. So just a reminder, how do we collect like terms? Like terms have to have the same variable and the same exponent. So for example, if I have this 5 right here, there's nothing else like the 5, so I would copy that down. There's no other constants. But then we have this 3y, and the other term that's like this 3y is this negative 2y because they both have y's to the power of 1. So if I have 3y's and I take away 2y's, then I have 1y left over. And then here we've got this negative 2x and this positive 4x. So team negative 1, 2 points, team positive 1, 4 points. So team positive 1 by 2 points, but it's x, so we have to say 2x. Now put this in descending order. It doesn't matter if the x or the y goes first. Typically we do it in alphabetical order, but the 5 has to go last. So now just a reminder, when we distribute, we always multiply the number that's outside of the brackets, multiply the monomial. So for example, right here, I would multiply the 5 to the w, so I get 5w. Then I'd multiply the 5 to the 3, and I would get positive 15. So this is what I get when I distribute the 5 through. In number 3, I would distribute 1/3 to 3x. So I want to multiply 1/3 by 3 over 1. Now the 3's cancel, they both become 1's. So I end up getting 1 over 1 or just 1. So I would get 1x. Now this 1 right here in front of this x is not necessary. So we typically would just say x. Again, because x and 1x are the same thing. Now I would multiply 1/3 by 6. This is 6 over 1, and I would see, well, 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 2 is 2. So I end up getting positive 2 over 1, which is just 2. So this is what I get when I distribute it. But think about it logically. This is just saying find a third of 3x, which is 1x. Find a third of 6, which is 2. All right, lastly, we've got negative 4 multiplied to the 2x, so I get negative 8x, and be careful here, negative 4 multiplied to negative 5 is a positive 20. All right, so now let's apply this information. So solve the following equations by first distributing, then collecting or combining like terms. So for example, in our first example here, we have this 1. There's nothing I can do with this 1 at this point in time, so I'm just going to copy that 1 down. But I do have this 7a that needs to get distributed to the a and to the 2. So when I multiply 7 by a, I get 7a. When I multiply 7 by 2, I get 14. Then there's nothing I can really do with this 5 or this 2a, so I just copy them down. So again, the first thing that we want to do is distribute. Then we want to see if we can collect like terms. But a quick note is that we can only collect like terms if they are on the same side. So for example, right here, I'm going to put the a's together. So I've got 7a plus 2a, so I end up getting 9a. And I also have this 1 and this 14, which is 15, plus 5, which is 20. So I would write down plus 20, and then I would copy down the equals 2. Now, I only combine or collect the 1, the 14, and the 15 together. Sorry, I meant to say 5, because the 2 right here is on the other side of the equation, so I do not put it together with the 1, the 14, and the 5. They have to be on the same side. Now, once I've done that, I can just solve this like a normal equation. So the first thing I want to do is get all my variables on one side and my constants on the other. So because I have only the variables, I can only see them on the left side. That means that I do not want this constant on the left side anymore. So I'm going to subtract this 20 over here. But whatever I do on one side, I have to do on the other side. So team positive won the 2 points, team negative won the 20 points. So team negative won by 18 points. Now just bring down this 9a. Okay, so now I got the variables on the left side, the constants on the right side, but I don't want to know what 9a is. I want to know what just a is. So since this is 9 sets of a, it's 9 times a. The opposite of multiplication is division, so I'm going to divide both sides by 9, and I get a equals, because 9 divided by 9 is 1, we get 1a, but 1a is the same thing as just a, so a equals whatever negative 18 divided by 9 is, which is negative 2. Okay, so let's take a look at number 6 then right here. So in number 6, same idea. The 4x, nothing is like it, so I'm just going to copy that down. Now I see a number that's ready to be distributed, and that's the -3. Make sure you distribute a -3 through. So -3 times 2x is -6x, and then -3 times 8 is -24. And just a reminder that we stopped distributing at this point because my brackets have closed. Then I copy down the other side of my equation, which is equals -12. Now I want to see, are there any like terms that I can put together? Well, I've got 4x and -6x. Those are like each other. So team positive won the 4 points, team negative won the 6 points. So team negative won by 2 points. And then I just copy the rest of this down. And I don't collect this -24 with this -12 because they are on opposite sides of this equal sign. They're not on the same side together. All right, cool. So now if you notice, I have variables on the left side and I have constants on both sides, but the right side only has constants on it, which means that this constant right here is no longer welcome on this side. So how do I get rid of this -24? Add 24. But whatever I do on one side, I have to do on the other side. So -24 goes. I bring down this -2x. And then I see, well, who won the game? Team negative won 12 points. Team positive won 24 points. So team positive won by 12 points. So now I've gotten the variables on one side, the constants on the other side. So now I just need to get rid of this times -2. The opposite of multiplication is division. So I'm going to divide both sides by -2. And -2 divided by -2 is 1. So I get 1x, which is what I'm looking for. And I get x equals -6. And I am done with this question. That's it for this video. If you have any questions, let me know. Otherwise, I'll see you in class. All right, see ya.